start the clock, please.
Challenge team of Georgia present problem number 14, granular splash.
Challenge problem is problem number 14, granular splash.
We accept.
Questions from the opponent?
Okay. First, hello, I'm João, and I'm going to make the opening for this problem. Could you go back to the first slide, please?
First slide.
Yeah, the first slide. Here we see that if two balls drop in a bed of dry sand, did you use sand in your experiment?
Now, at the beginning we tried to use sand, but since the grain size was too large, we couldn't get the jet and couldn't find a very fine sand, so we used the baking soda, so there's not a big difference.
So you couldn't reproduce the phenomenon using the sand?
Yes, but the soda is very close to the sand, so...
Okay, but no.
Okay.
Okay. Could you go to the next slide, please?
Presentation plan.
Yes. Again, the order. You mentioned the particle size. How bigger is this precision of the size of the particle?
Sorry?
The particles are regular. You have the regularity of the particles. Is big or no? You don't have a precision here. What's the precision of this size?
What can be the maximum size and minimal size?
Yes. Because the size is not regular.
Yes, I know, but the main amount of grains are like this.
Do you think that the way you put the granular material there is important? The compression of this initial compression?
We try to aerate the soda in order to get this, it more similar to food, so that this void collapse would act.
And how do you control this compression? This initial compression of the...
We tried not to shake the vessel so that these grains were not compressed, and we.
Okay, time's over. Okay, please start.
Good morning. I'm going to make the openings for problem 14, granular splash. First of all, I would like to congratulate the reporters for the good presentation. You talk about void collapse and the void penetration, have a good use of media, and conclude that dense waves are the most important parameter for the problem. About the theory, you have a good explanation of the phenomenon cause and code the direct force. But the negative points, you do not evaluate the humidity, lack of compression analysis, as discussed in the questions. You do not define the critical depth for comparison, and fluid and solid features relations not gotten if you can or not consider the sand fluid or solid. Really, stability is not evaluated, and you have you don't analyze the splash. You have not a deep analysis of the splash. About the experiments, good use of media, that was really good. You have energetic approach and height analysis. The negative points, you don't have no dissipation analysis, no quantitative analysis with possible comparison. The compression is not changed. The inner jet not observed. Sand is not used, unfortunately, and the problem asks for the sand. Some errors are not evaluated, and you don't have a quantitative comparison with your theory. And that's it. Now I'd like to discuss about some points with you. Okay, you mentioned the hydrostatic pressure. You think you can consider the same of the material you use as a fluid, or what limits we can consider this?
Well, we can haven't calculated exactly the limit, but for our case, we could consider this baking soda nearly similar to liquid.
Liquid.
Yeah.
You mentioned the friction
Yes.
in function of the distance, right?
Yes.
You mentioned this hydrostatic pressure. Do you agree that we have a kind of drag force acting these two balls?
Drag force.
Yes. But this drag force, do you agree that's proportional to the square of the velocity of the
Yes.
ball? And this influence in the friction, do you agree?
Yes.
A lot. So how can you compare the friction only in function of this distance? If we had this force that changes this distance, that's not an linear.
So that's why we couldn't calculate exactly the scaling factor, because we considered only these forces and separately. So we couldn't get the scaling parameters so that we could consider both forces together. But the shape of this,
You couldn't analyze this, but if you influence in your equations,
yes,
I don't think it's part to mention because it's not.
we mentioned that depth dependent
Do you
force.
agree with me that's not that usual because we have this variation of the velocity,
I understand.
in this way with the drag force we change this velocity and change the friction
Yes.
of the system, so we don't have only this friction in function of the distance.
I don't understand what you want to tell me.
Yes, you have this drag force.
Yes.
It's proportional to the square of the velocity.
Yes.
And with this we have the
Friction
variation of the
Yeah.
friction force. Okay, so it's not only the variation of the distance, but to this variation of the velocity. They are correlated.
Yes. So as I said, we should consider both forces together, but since, as I said, the scaling factor second was not estimated, we couldn't consider them both together, but separately we consider both the friction changing and the velocity.
Yes, I don't agree with you because we need to use these equations correlated because they are correlated.
Yes, I agree with you that we need to use, but we couldn't calculate exactly the scaling factor, which is very important.
Okay. Could you define again these density waves?
Yes. So this is sand. When the ball hits, I can show you my experiment.
One question. Do you analyze this critical depth for the void collapses?
Critical depth of
Yes, you have depth where, as you showed, you have this collapsing of the void.
yes.
Could you measure this or calculate or have an equation for calculate this depth and the influence of the jet formation and the height of the
It depends on the velocity of penetration,
And you have an equation for this?
I haven't written it.
Okay, but you can mention what's important for this critical depth?
Yes.
What's the parameters that
For example, penetration depth,
okay,
how wide the ball is, of the radius of the ball mass.
this hydrostatic pressure you mentioned, do you think it's important for this?
Yes.
How important and how do you think that it will influence in this?
The larger is the pressure, the larger will be the collapse force, and the larger will be the jet.
And the critical depth will increase or decrease with this pressure? Increasing of this pressure will increase or decrease the critical depth?
So it depends on the place. For example, when the ball
No, yes.
penetrates here, the pressure is low, but it starts early. here the pressure is high, but the process starts later.
We have
even more.
this distance here.
Yes.
For one determined pressure, you have one distance. If you increase or decrease the pressure,
Yes.
we will increase or decrease this critical depth.
I think it will go somewhere. It will decrease the critical depth.
Okay, I agree.
Can I?
Yes, I agree. Then you.
So here, as we saw, when the ball penetrates the sand, here you see, it pushes the sand to the sides and downwards. And when it penetrates with high velocity, this density can travel.
Yes,
in the
you're
sand.
analyzing these with sand, but in your experiment you analyze with another
We
material.
made this.
The behavior is similar.
Yes, because
How can you prove this to me or show me this?
I showed that I showed for different this depth waves and non-depth waves in soda, and you see that if waves are depth, the height is much lower. So this means that waves are created.
Yes,
and
but you're with me. You extend. You couldn't reproduce with jet, okay?
I couldn't reproduce. I could reproduce with soda, but
I'm
I
sorry,
couldn't.
let me finish.
Okay.
You use sand and you couldn't reproduce the phenomenon, and you show these waves, okay? And you use to reproduce the phenomenon another material.
Yes.
And how do you show me that these waves is what makes the jet formation in that material?
The structure of
Because
this.
you don't have the jet with sand, and you have jet with the other material.
Yes.
And you have this behavior with sand, so
I just showed
cannot
this.
conclude that you have the behavior with the other material.
I just showed this in case of sand because it's more visible. I've tried at my home to put the same into soda, but since it's totally white, we couldn't clearly see, so I used sand to make it more obvious.
And the problem, how do you think that we could reproduce the phenomenon with sand?
Make the particles more fine, and then we could.
And what the parameters that make this happen or not? What the parameters you think that make it impossible the reproducing of the jet?
The large grain size is the main thing that.
And the humidity of the sand is not important?
It is important.
For
the
the
forces-
things that increasing with is easier or harder to reproduce?
I think that increasing the humidity will make this sand more similar to liquid, and it will be better for the white collapse.
Okay, I don't agree with you in this case.
Why?
We increase the humidity, you have a compression in the sand, and here we won't have the particle won't fall. It will compress before it falls, and we won't see it splash or.
It depends on the amount of water in the sand. So for some value of humidity,
Yes,
the
you
sand
can
will be
have water
compressed.
with a small quantity of sand, so we want. It's not a phenomenon. We have. It's different. Do you agree?
What
You can put water and some grains of sand. It's not the case.
Yes, but when the humidity increases, for some case the sand can be more compressed, and when humidity is really high, this can be more like fluid. It changes its parameters.
And do you evaluate this?
I haven't evaluated this,
Okay.
but
Can you go to your graph?
which graph?
I don't know the slide.
This?
No. No. This.
Yes.
You can see that you have the both graphs are with your errors. They are basically the same. How can you conclude something with that?
With what?
The errors of both are in the same fits. The fits are equal with your errors. Do you agree?
So both fit my errors, yes.
Yes. So what can you conclude with this graph?
I can conclude that, what do you mean?
Yes. You said, but look, all the points, the red and green points,
Yes.
with your analyzing with the errors are basically the same.
Yes.
So the variation, you could analyze this variation that you use.
As I said, I measured both forces, and both forces exist. So in order to conclude something clearly, we should, as I said, consider them together, simultaneously.
And And the size of the seawall, do you think that's relevant for the problem?
The size of the bolt, yes, because it can change the height of collapse, depth of collapse and height of the jet.
Yes, but do you think that will influence too in the friction?
Yes.
Also in the friction.
Yes.
So increasing the size of the ball,
Yes.
we have to have a bigger jet or a lower jet.
It depends on the density. We use the same ball of the same density.
Yes, yes.
It also depends on drop height because
Yes,
mass increases,
the
so
same
it can
conditions. The same conditions.
the same conditions. So anyway, I think it depends on the drop height.
Yes, the
Because-
same conditions, the same drop height.
Yes, but we can for one drop height maybe one ball is.
I'm sorry, you could clearly answer my question. I believe that increasing the size of the ball will increase the jet, the height of the jet in the same conditions, the same height, the height of releasing, and the same conditions, only increasing the size of the ball, increase the jet, the height of the jet, increasing the pressure that you mentioned.
I think I agree that it increases because the velocity of the ball penetration is higher and.
You have a big analysis of the splash?
Deep analysis?
Yes, bigger.
Of the crown light splash.
Yes, the first splash.
We focused on mainly on the jet because
It,
I think it's main thing in this phenomenon. And
I don't agree. I think it should be better you analyze both. The splash
so
and the jet.
then we should delete some parts of this which are.
But do you have another analysis? Can you tell me a quick analysis of this splash?
No, we haven't analyzed because we couldn't put everything into this
Yeah,
presentation.
not in the slide, but you
So
observed
we didn't,
something, some pattern or anything.
As you said, we focused on we didn't calculate the parameters of splash because we thought we think that the jet is most important phenomenon in this case.
Okay. And the second splash, the second jet,
Yes.
what happens on the relevance of it? You have when the ball falls in a with a height bigger than the spherical dip, we have another jet formation, as you mentioned.
Yes.
And how at this another jet, what happened to it?
As I said, it's the lower air pocket tries to push up the sand, and in it
Okay.
increases the height of the jet, and here's the thicker part which is created by this air pocket.
Okay, thank you. Time is over.
Okay, we'll start. Some final considerations. First, I'd like to thank for the good discussion here. And some points that I'd like to emphasize. Do not consider the interrelation between drag, depending on the spread of velocity, and the friction dissipation, depending on the distance. They are correlated. I'd like to be better to analyze them together. The comparison with the theory is not possible with the mathematical model, in our opinion. And as you could see, some variations of parameters in the experiments could clearly be defined due to these errors in the experiment. Does not talk about the compression, how they could keep the compression constant, cutting the material for the releasing of the ball and the jet formation. Says that the phenomenon could not be evaluated for the sand, as was asked in the problem. And compression is not evaluated experimentally, and that's one of the main influence parameters in the problem, because it could vary the formation of the jet in the splash. So thank you for
Thank you. Questions from the review?
Questions. First of all, reporter, did you investigate the splash?
As I said, I didn't investigate. I focused on jet.
Okay, so do you think the splash is important, especially since the question asks for a splash?
It was in the question. The splash projection of
Which maybe occurred.
projection of vertical column of sand.
Okay, thank you. Furthermore, it says that the question says maybe followed by vertical column of sand. So the meaning suggests that the sand may or may not occur. So the vertical column may or may not occur. Do you investigate when it occurs and when it does not?
There are some critical conditions
But
where
do you investigate when these critical conditions occur?
we didn't calculate exactly.
Thank you. I'd like to ask, what parameters do you change to vary your threads?
I changed mainly it was we tried different sand. For example, we tried sand and soda. We tried also different shapes of this and shape and structure of walls, different walls.
Yeah, thank you. I want to ask the opponent, which factor among these do you think is the most important?
The compression of the sand that makes the phenomenon possible or not.
Okay, does this have anything to do with the humidity?
Sorry?
Does this have anything to do with the humidity?
Yeah. Oh, sorry. Yes.
Okay. I like. Okay. Furthermore, did you vary your particle size?
Yes. I'm sorry.
Did you vary the size of the particles?
No. I used large particle sand and
Yes. No, because earlier on I realized during your discussion, the particle size came up, and that was something that's somewhat important on your jet formation. So yeah. Okay.
yeah.
I'll
So
go into that later.
for larger particles, the jet wasn't formed in case of sand.
Okay, for your jet, when you measured your force, your resistive force, when you pushed the object into the sand,
Yes.
how slowly was it being pushed?
It was quite slowly pushed. I haven't exactly calculated, but I pushed as slow as I could.
Okay, because I feel you pushed as slowly as you can, despite the fact that in reality the ball is going down rather quickly.
We just plotted the experimental, did the experimental measurements in order to calculate the scaling factor of the
Okay,
Earth.
opponent, do you think his method of measuring the resistive force is adequate?
Sorry?
He measured the resistive force from the sand. Do you think this is adequate?
No, as I mentioned, they must be correlated with this drag that influence
So
also
it's not very
influences.
important. Sorry, not very adequate. Okay, thank you. Okay, and how did you measure your jet height? What do you define your height of your jet?
I define height as
Yeah, because what I noticed is your jet is curved. So how did you measure?
I measured the maximum point of.
Okay, thank you.
Okay, thank you.
Okay.